Good morning. This is Dr. Huang. Welcome to the first experiment of this semester. Determine the density of an unknown liquid in insoluble solid. Here, I am going to use this experiment to illustrate how to prepare for an experiment. In other words, I will show you what you need to do before coming to the lab. The first thing you need to do is to read your handouts and find out the experimental purpose. After you read your handouts, you find that the experiment purpose is to determine the density of an unknown liquid and insoluble solid with 4 sig figures. To determine the density of a liquid may not be difficult. You probably have done this in high school. However, to obtain a 4 sig figure density with the electronic balance and a graded cylinder is a different story. In modern labs, a lot of measurements can be done by instruments directly. Therefore, some of you may ask me, is there an instrument that can measure the density directly? The answer is yes. However, we do not have it here. So, you may need to look for an indirect method. If you recall, in class, we have learned that density is defined as mass over volume. If we can measure both the volume and the mass of a liquid, the density can be calculated. The most common device in a chemical laboratory to measure volume is a graded cylinder. Here shows a graded cylinder with some liquid in it. Can you read out the volume of the liquid? As we can see, the bottom of the meniscus is between the third and the fourth mark after 6 milliliters, or we say the volume is more than 6.6 milliliter but less than 6.8 milliliter. As required, we have to estimate one more digit. I estimate the volume would be 6.61 milliliter. In this case, we only have 3 sig figures. Before we move to the next step, I want to emphasize, when you read the volume, your eye should be at the same level as the meniscus. Your eye should be at position B in my slide. The device we use to measure the mass is an electronic balance. How many sig figures can we get with the balance shown here? Let's count together. 1, 2, 3, 4. So, the maximum number of sig figures with this balance is 4. If the mass has 4 sig figures and the volume has 3 sig figures, how many sig figures are the calculated density? It turns out that we can only get to the density with 3 sig figures if we just use the electronic balance and a graded cylinder directly. What should we do? One way to solve the problem is to relabel each mark of the graded cylinder with better precision, and this is called calibration. Here shows a table of the densities of water at different temperatures. The unit is gram per milliliter. Let me show you how to read this table correctly. If you are looking for the density of water at 20.0 degrees Celsius, you find 20 in row number 2 and 0.0 in column number 2. At the intersection, you find the number. That will be the density at 20.0 degrees C. So, the density of water at 20.0 degrees C will be 0.99820 gram per milliliter. If you are looking for the density of water at 20.5 degrees Celsius, you find 20 in row number 2 and 0.5 in column number 6. At the intersection, you say 0.99. In this case, you use the first first four digits before the number you find in the table. So the density at 20.5 degrees Celsius is 0.998099 gram per milliliter. For the third case, we are looking for the density of water at 25.5 degrees Celsius. Use a similar way, we find the reading is star 914. Whenever you see a star, you take the first few digits from the next row. In this case, the density of water at 25.5 degrees Celsius will be 0.996914 gram per milliliter. Now do you know how to use this table? Let's take a look at the density formula again. After rearrangement, volume is equal mass over density. If we use water as the calibration material, we can get volume with 4 sig figures. This is because mass has 4 sig figures and density has 6 sig figures. After calibration, we get a better graded cylinder. The reading at each calibrated mark has 4 sig figures. Let's go back to our original goal. If we use water to calibrate all major marks, 2, 4, 6, 8, and 10 milliliter marks, if we add liquid to the same marks, the volumes of the liquid will have 4 sig figures. Since the mass has 4 sig figures, the volume has 4 sig figures, and the density should have 4 sig figures as well. Here is a recommended procedure and table to record your data. You only need to take 12 measurements and you will be done. It should not take longer than 15 minutes. Thank you. Have fun.